All right. Hello, everyone. Welcome. Let's start. Actually, we have more than 50 people already, so I think it's good enough. So let me quickly start sharing my screen. Okay, you should be able to see it in a second. Here we go. Please let me know if you have any issues, like if you can't see my screen or if you can't see me or hear me, whatever. But otherwise, I think we can start. So today we have our lesson number 18. Congrats. I've seen that in the chat. You are really close. It's almost there. Today we will talk about test automation, actually. So as a heads up, as a manual QA engineer, right, you will not be doing any kind of coding, scripting, test automation, anything like that. But when you join a QA team, most likely you will see test automation engineers. These days, usually QA teams are mixed, which means we have a few folks who do manual testing and usually a couple of automation engineers. So it would be useful for you to understand who they are, what QA automation engineers actually do, why do we need QA automation, what is QA automation, what's the difference between manual testing and automated testing, and that's what we're going to talk about today. So as always, if you have any questions, just post them in the chat, so I will answer them. If you want to ask a question in a way where only I can see it, you can do that too. Just pick my name from the list of participants. And then when you ask a question, I will see it, I will read it, and I will answer it. Just a reminder, my name is Lana. So yeah, that's all I wanted to mention here. And I think we are ready to begin. Cool. So let's start. Oops. So the first thing I wanted to talk about is what test automation is and what kind of benefits we get from it. I'm sure some of you are already familiar with the concept of automation. Maybe you started to like quickly look for jobs or like, you know, explore job descriptions and things like this. And that's probably something that you've come across. So in simple words, test automation is just a way to test our software that uses automated tools in order to execute test cases. That's it. So when we test something manually, for example, we usually take our device, then we start executing some test cases. So we like open a test trail or maybe like Google spreadsheet with test cases, whatever we have. Then we take our device and we start like executing test cases, right? Step by step. And then at the end, we always verify that whatever we see in the app matches what we actually expect to see. So our actual result matches our expected result, right, from the test case. When we do test automation, we basically do the same thing. The only difference here is that instead of like taking the device manually and manually clicking on the buttons, QA automation engineers will actually build a script that will do that for them. So test automation engineer can create a script using programming language. So the script will actually connect to a mobile device or a browser, whatever we're testing. And then it can execute the steps of our test case. So for example, it can open login page, it can enter email, password, it can click on login button, and then it can automatically verify that user is logged in, for example. So that is test automation. Now, test automation has some benefits. First of all, and you will see today, test automation is really fast, especially if we have a lot of test cases. Let's say if we have like 300 or 400 of test cases, running them on web would take probably around like 1 hour, maybe 1.5, but usually no more than that. For mobile, it's a little bit slower, but usually you can also run them all within a couple of hours, no problem. So because it's so fast, it saves us a lot of time. It's also reliable because it's just the code that people create. And then like people run this code, so it's stable. It's just a sequence of some commands. So therefore, we get reliable results, and there are no human errors and things like this. It is reusable. One of the main points to actually have automation is because it's reusable. So usually people create automated tests once, and then they just rerun them. So if I, for example, need to automate login functionality, I build login test once, and then every time I need to retest it, I just hit the play button and the test will run and it will just retest things for me. So also at first, test automation is a little bit more expensive to implement and definitely more expensive than manual testing. When we have a decent set of test cases covered with automation, and when we start reusing those test cases, this is the time when we usually start seeing a lot of benefits, and this is usually the time when we start seeing cost reduction for QA, because we no longer have to spend days on like manual regression, and instead we can rely on automation, and it will retest a good amount of functionality. So ideally, test automation increases the test coverage. This is the benefit that we usually get when we have a mixed team. So these days, it's actually recommended to have a mixed team. So we have manual QA engineers and QA automation engineers responsible for different areas. And then when we have a mixed team of engineers, all the repetitive stuffs like smoke testing, regression, things like that will go to test automation. And then all kinds of like new feature testing or creative edge case testing will go to manual QA engineers. So as a result, we usually have a really good test coverage where all the major functionality is covered by automation, and then everything else is covered by manual QA engineers. So usually that's also one of the main benefits here. Okay. Let me actually check the chat and then we'll talk about the next thing. Is this like a test case? So test automation, it's like executing manual test cases, but it's just writing code that will execute it. The core of QA stays. It's always test case execution. Test automation just has a way to automate that execution. That's it. Nothing else is invented here. It just executes things for you. And then there are a few comments about like, it looks better than manual. Will test automation cause layoffs for manual QA and things like this? And why do you need manual if automation saves time and money? So long story short, these days it is recommended to have a balance and to have test automation and manual QA engineers working on the same project. One of the main reasons for that is that you should use a certain tool or a certain group of people for certain responsibilities. So for example, everything that is repetitive and everything that we retest again and again and again, it's better to give to test automation and engineers will just automate it. But not everything is repetitive, right? Not everything should be automated. So for example, if you test a new feature, most likely that feature will be just tested manually. Then we will release that feature to our end users. We will watch them. We will see whether they like it or not. We will decide whether we're going to keep this feature or not. And then only after we decide that, okay, we're going to keep it, then we will start automating it. So this initial testing of the new feature is usually done by manual QA engineers. Also, all kinds of temporary functionality. For example, let's say you test online e-commerce website where you can buy products, and on that website you have like Black Friday deals or Christmas deals or whatever else, like all kinds of sale events. Those kind of events are usually very short term, right? They will be on the website for a couple of days, maybe for a week, maybe for 2 weeks, but that's it. After that, we're just going to turn them off and forget about it. So those kind of things we usually test manually. We don't automate it. It just doesn't make sense to waste time on automation and then just throw it away. Edge case testing is also something that usually people don't automate. So like actually going to the app and like trying to do all kinds of random actions and trying to break it. This is kind of a creative activity that manual QA engineer would do. But from automation perspective, it doesn't make sense to waste resources on a lot of edge cases like this, like opening an app and tapping on the button 5 times, making sure things are fine. This is something a manual QA engineer would do, but not automation. Automation doesn't really care about cases like this. Automation, again, is more about like covering regressions. So manual QA engineers, instead of like going through hundreds of regression tests, can now actually concentrate on more of a creative tasks and test something else. So ideally, you want to have a balance. That's basically the idea here. Let's see, I think there were more questions. Do we have someone in our class who get automation? So long story short, today we will have like one class about automation, right? So I will explain the idea of what it is. And then if you're interested in automation, you can like dig a little bit deeper into that. I will give some resources. If you're not interested, that's also totally fine. Again, it's not expected from you to automate anything. So you can at least, just know the basics, and hopefully when you have an interview, you can just answer some like super basic questions about like what test automation is and why do we need it. That's it. Yeah, and somebody also asking me, do companies have automation and manual at the same time? Yes, so as I mentioned, most of the companies will have a mixed team. And for most of the companies, you usually see one QA team that will have a couple of automation engineers and probably 2 or 3 manual QA engineers on the same team. Cool. All right, so I hope it answers everything. If I missed something, please post it again. But let's continue and let's talk a little bit more about like the system and the approach and everything else. So the next thing I wanted to talk about is test pyramid. Test pyramid is actually a really common concept in QA industry. If you ever, by the way, go to a QA meetup or QA conference, like literally every second person who presents something, or probably like 2 out of 3 people who will be presenting something, will have a slide in their deck that will be devoted to test pyramid and how they try to implement it in their company. This is something super common. So test pyramid is the concept that basically tells us that when a company delivers software and just builds software, they also have to implement automation and add it on different layers. If we have automation and build it while we are developing software, we will be able to discover issues quickly, and the price of our bug fix will be pretty low. So this concept was originally defined more than 10 years ago, actually, already in 2012. If you are interested in the original blog post, the slide number 2 has a link that will take you there, and you can actually read about it. But basically what test pyramid tells us is this. When a company develops software, when they just create the source code for that software, right, like files with lines of code, they have to cover that software with unit tests. So unit tests is something that we see on the bottom of our pyramid. And basically when developers create software, at the same time, they should be creating unit tests for that particular software. So unit tests are the slowest level tests that should literally automate everything that developers do. So for example, developer created the function to, I don't know, like put something in the cart and calculate the amount of items in the cart. They should create a unit test that will simulate that activity and will check that the calculation is correct. So developers are responsible for unit tests. This is, again, not area of QA. This is the area of developers. And unit tests are created in the same code repository as the source code, right? So basically, when developers create code, they put unit tests in the same code repository. In many companies these days, they use like special tools to actually calculate how much of the code is covered with unit tests. And ideally, these days, companies try to achieve at least 95% coverage with the unit tests. So basically, 95% of the code base or more should be covered with tests. Very often in modern companies, they will also have like limitations. So for example, if a developer wants to make a build and give it to QA or whoever else, before they can do it, all the unit tests must pass. If they don't pass, developers have to actually look in the issue and fix it. So that's why the price of a bug fix here is super low, because again, it's just developer working with their code. If unit tests discover bugs, developers will just fix those bugs right away. It will never go to QA or anyone else. So the price of a bug fix is very low. Also, unit tests are really quick. So sometimes they take milliseconds to run. Sometimes they take seconds, but usually no more than just a few seconds. So that's one of the reasons why they are so efficient. So ideally, companies should have a really good unit test coverage. Now, if we go one level up, we'll get to service layer tests. So here we should also have tests that will usually verify that multiple components of our system work together and there are no problems. So for example, we may have a test case here that will check that our backend server can connect to the database and run a SQL like select statement in the database and get the information back. Right, so that would be a service layer test to verify that our backend can communicate with the database and get the information, for example, or update the information or whatever else. So these tests are also responsibility of developers. They usually are a little bit slower to run because multiple components are involved. The price of a bug fix here is a little more expensive because, again, multiple components are involved. So sometimes it's not clear what exactly broke, and it takes a little time for developers to actually figure it out and fix. And then if we continue and we go one level up, we'll go to UI layer. So UI stands for user interface. And this layer is basically the land of QA. So this is where QA automation engineers live and create their own test cases. So UI automation is called UI because it's automating a behavior through user interface. So for example, if I need to build an automated test case for a login, my test case will actually connect to a browser or a mobile device. It will open login page. It will enter email password. It will click on the login button, same exact way as a user would do. And then it would automatically verify that user is logged in or something else happened. So these tests are the slowest ones to run, simply because we have to connect to the right environment. So if I create test automation for web, I actually have to connect to the web browser before I can run it. If I create test automation for mobile, I have to connect to a mobile device. So that's a little time consuming. And because this is the land of QA, if QA automation engineers find a bug, they will report this bug. So this bug will basically will be filed in Jira, then it will be assigned to a developer, then developer will fix it, then they will send it back to QA. So because there is some back and forward with this whole process, the price of a bug fix here is the most expensive, simply because multiple teams are involved. So this is what test pyramid is, and this is basically the core concept that is pretty important for automation, like basically from automation standpoint. Now, test pyramid was evolving a little bit with time. So this is how it's recommended to build things these days, right? So this image on the right side. So again, developers should create a lot of unit tests, a lot of service tests. QA automation engineers should have a lot of UI tests. But on top of everything, it is also recommended to have manual testing. So manual QA engineers will cover things that cannot be automated or shouldn't be automated, all kinds of edge cases, and just provide like additional check to make sure that everything is good. Now, if you join a company that has something like this implemented, usually that's really good for you because all the core functionality will be automated. So all the tests for login, registration, user creation, payments, all the like main features will be covered with automation. And then as a manual QA engineer, you mostly will be responsible for testing all the new functionality. That's literally where like pretty much all your time will go. And just doing a lot of like additional testing on like maybe multiple devices, like cross-platform, cross-browser testing to make sure that app looks good, and like basically UI elements don't overlap each other, things look fine. But you won't have to do a lot of like regression, smoke testing, and things like this, because all those things will be covered with automation. Now, this kind of environment is also really good because all the core functionality is automated. So if something gets broken, especially something that is really important and critical, it will be caught by the tests. It literally has like 3 layers of checks. One of them will definitely cut the critical issues. Most likely all 3 will do, which means that this issue will be noticed and developers will fix it. So here, you don't really have to worry about like missing critical issues to production because it will be really covered very well. So you don't like really have to stress that you may miss a very important bug. And again, most of the testing will be just new features and things like this. This being said, unfortunately, not every company has it and has this balance. So we also have this anti-pattern that you can see on the left side. Some people call it ice cream cone pattern. So this is what happens when automation is just not there, or when the company lacks automation. So if, for example, the company doesn't have unit tests, or maybe they have unit tests, but they never run them. Or they don't have integration tests, or they lack automated UI tests. Basically, all the bugs that could be potentially found here will actually make it to this layer. So as a manual QA engineer, you will be testing a lot of things. You will be doing a lot of regression testing, and most likely you will be finding a lot of bugs. Now, you will be reporting those bugs to developers, but because nothing is automated here, when a developer fixes a bug, there is really a good chance that they will break something else. It just happens. So when they will send you a bug for verification, most likely that bug will be fixed, but then you may discover another one, or maybe even 2 in like related functionality. So usually this kind of approach is really unhealthy and not scalable. So sometimes it happens with the new companies that like don't have a dedicated QA engineer or a QA manager, or maybe if they don't have like a professional manager who actually understands how to build the teams properly. One of the worst things here is that the company who like don't really know about this pattern, like the managers who don't really know about this pattern, will try to fix the problem by hiring more manual QA engineers. Now, with having more manual QA engineers, more of the people will be finding bugs. So developers will be fixing like a bigger amount of bugs. There is a bigger chance that they will break something else. So we will have like this constant slow testing period where we will just still be finding issues. Not ideal. So that's why automation is important. Another problem here is that it becomes pretty stressful simply because you are like literally the only person or the only team who's responsible for signing off and saying like whether this build is good to go to production or not. And if something is broken, technically, basically the responsibility of your team. So it's also pretty stressful. Sometimes it also leads to longer releases simply because testing takes a lot of time. So with a company like this, we will see releases maybe like once per month or per 2 months. And usually company management is not really happy with this process because usually companies like try to push faster and they hope to deliver faster. So users gonna get like new features and new experience faster. It's important from the competitive standpoint. So this is like not very healthy. Just keep this in mind. If you join a company and you hear some red flags, for example, developers say something like, oh, we don't want to create unit tests, we're not testers, or oh, we had integration tests, but then they started to fail, we never fixed them, we forgot about them, we don't have time for that. That is another red flag. So if you hear something like that, it actually makes sense to bring it up to an engineering manager or a QA manager if you have any QA manager, and try to improve this process because it's not going to be good. It's not going to end well. So just FYI, if somebody's asking you during maybe an interview, like, have you heard something about test pyramid, or like, what is the main idea? This is it. This is it right here, which basically just tells us that there should be balance. And when we build software, we should also build automation. That's important. All right. Let me know if you have any issues. I'm sorry, if you have any questions. And then we'll talk about the next things. Let's see. Cool. Yeah, if you folks are interested in automation, that's great. Actually, if you have any questions about automation course, definitely feel free to ask. And I will be talking about it a little bit later too. Okay, do you also automate writing test cases or just executing test cases? Automation is only execution. So usually manual QA engineers are responsible for test case creation. And then when they have test cases, automation engineers very often just use those test cases written by manual QA engineers and automate them, just basically turn them into automated like executable steps. So if a test case is automated, manual engineers no longer have to test it. So for the ice cream cone, you said no automation. So it could be no automation. It could be just a lack of automation. Like maybe they have a few test cases, but only a very, very small amount of them, and they don't cover everything. So basically, it's a pattern when we have a huge amount of manual work and manual testing and lack of automation coverage. That's it. Okay, and let's see what else. The test pyramid provides faster feedback than the inverted pyramid, that's for sure, because like when developers actually change something, this automation will kick in and will discover issues pretty much right away. Or maybe will not discover issues, which means that everything is fine. Yeah, that's a good point. Okay, so what can be automated? Pretty much everything. So we've already talked about like unit, integration, APIs. If you remember our lesson number 9, when we were talking about client-server communication, request response, so that's APIs. So APIs could also be automated. And then literally everything that has interface, web pages, mobile, iOS, Android, desktop apps, all those things could be automated. All right, so what do QA automation engineers actually do? I think you already have the idea, but let's summarize. So QA automation engineers are responsible for building test automation. So they use a programming language, write some code, build automated tests. Then they also execute those tests. So they run them and they analyze the results. If, for example, we have, I don't know, 300 or 400 of test cases and some of them fail, QA automation engineers are responsible for checking the failures and making sure that these failures are actually not not related to bugs. So if an automated test case fails, it could be a problem with environment or a test itself, or it actually could be a bug. So QA automation engineers will check the failures. Usually they do it every day. So usually test automation runs at least once per day. And then if something fails, automation engineers will check it. If they see a bug, they will report the bug in Jira. Absolutely the same way as a manual QA engineer would do, like literally the same way, all the same Jira fields and everything. If, for example, the test fails because of something else, like maybe the problem is with the test itself or with environment, QA automation engineers are responsible for fixing it. So the test doesn't provide basically false failures. And then QA automation engineers are also responsible for maintenance. This is actually where most of the time usually goes. So when they build test automation is really connected with our app. So for example, if we automate registration form and like our form has, let's say, 3 input fields, test automation will literally connect to every one of those fields and will validate that we have 3 fields, we can fill out all the data, we can register successfully. Now, if the product requirements change, for example, product manager comes over and says, hey, we have to change our registration. We're now going to have another couple of fields, and then developers change it. A good automated test case should start failing because something changed. It could be a bug, right? So QA automation engineers will actually go to that code and will fix it so it matches with the latest requirement. It matches with the latest product. So that usually takes the biggest amount of time, just maintenance and updating those test cases. And then QA automation engineers also help in manual testing, not all the time, depending on the team, but usually when needed, they do, especially before major releases, because before the releases, QA automation engineers don't really have a lot of responsibilities. Their main responsibility is to run all the tests they have and make sure that everything is like fine. If there are bugs, report those bugs. That's it. So they can also like jump on manual testing, help like finish some testing, and like validate build before releases, just so the team has extra pair of eyes that never hurts. So that's when QA automation can help with manual, but that's pretty much it. Most of the time they just work with code, run and build test automation. Okay, so today we will actually build an automated test case. I mean, I will build an automated test case so you have an idea of how it's done and like what automation is. Before we get there, let me know if you have any questions. So I'll answer the questions and then we'll talk about this. Okay, let's see. That's my favorite painful question. In your experience, what is the ratio to developers to manual QA? Like, will there be jobs where we will be the only QA engineers? So ideal ratio should be 2 or 3 QA. I'm sorry, 2 or 3 developers and 1 QA engineer. So usually companies that build something that is pretty important and really care about quality will have more QA engineers. So for example, all the healthcare companies, all the fintech companies that work with finance, banking industry and things like this, they will have a lot of QA engineers. So basically they will have like a team of 10 developers and at least 3 QA engineers in there. This being said, it's not always like that. Especially in early stage startups, there could be a possibility where you will only have like 1 QA engineer per, I don't know, like 6 or 7 developers. That's totally possible. In the company where I'm currently working, we actually have 3 QA engineers per 50 developers. That's like the worst ratio I've ever seen in my life, but somehow it works. The developers actually assist and do a lot of testing. So sometimes it happens. There could be a chance that you could be the only QA engineer and there are going to be a team of 10 developers. Not really common for bigger companies, but for startups, it's actually possible. But like, don't be too stressed about it. That's all right. You can just create test cases, execute test cases, and like just follow the main processes, and it'll be fine. Okay, so then there are a few questions about languages. So yeah, we will talk about it, but basically currently there are 3 languages that are really popular in test automation. They are Python, Java, and JavaScript. Number 1 is Java, number 2 is Python, number 3 is JavaScript. But with this being said, Java's popularity has been decreasing. So over the last 3 years, we've noticed that there are less and less jobs with Java, and more companies, when they build new automation systems, they will pick Python or JavaScript. So usually pretty much no one uses Java these days to actually build automation from scratch. It's just like too complex, too much code. So people usually don't go with this choice anymore. But because Java was so popular like 10 years ago, 5 years ago, it was still popular. There are a lot of companies that already created the frameworks with Java. So that's why it still stays as number 1 in the market. Python popularity is growing, JavaScript popularity is growing too. So if you are thinking about learning automation, my recommendation would be to go with Python, just because it's currently number 2, its popularity is growing, and it's the easiest language out of these 3 to learn. And then if you don't like Python for some reason, my second choice would be JavaScript. I probably wouldn't recommend you to go with Java right now, because most likely it's not going to be as popular in a couple of years. So maybe you'll get a job, but most likely you will still have to switch to something else. Okay, let's see. So I think I answered this question already a few times about like, why would manual QA be needed if there are automation? Maybe like if you join late, you can just rewatch the beginning of the video where I explained that in the concept of test pyramid and why we should have a balance. Okay, let's see if there's anything else I haven't covered so far, but I think that's pretty much it. Cool. So yeah, QA automation engineers, when they analyze their test failures, they can see whether it's a bug or whether it's a problem with a test simply by reproducing it. If I take the app, reproduce behavior of my test and see that app is misbehaving, that's a bug. If the app behaves normally, but my test is failing, something's wrong with my test. That's it. But again, that's just only applicable to automation. That has nothing to do with manual. Okay, so as I mentioned, today we will try to do small, like a simple automation. So this is what I want to automate. I want to go to Amazon. And then I want to search for something. So I want to automatically open this page. And then here we can search, for example, for coffee. I want to verify that the search word Usually in test automation, we would do something that is a little bit complex, like we would actually check the results, make sure they have like the word coffee or the right category. Today, just for the sake of example, let's just check that we see this text coffee in here, right? So this one, which technically confirms that, okay, we are on the page with the search results. This text is not on the previous page. It only appears after we search. So that's basically what I want to do. Search for coffee, land on this page, make sure we see text coffee in here. So that's the test case that I will be building. Now, please watch, right? Please don't try to repeat after me. If you are interested in automation, again, I will provide like some materials a little bit later. But for now, you can just watch and at least try to get an idea. Again, as a manual QA engineer, you will not be building this. So the first question is, what do we actually need, right? So if we want to build this, what kind of things we need to have in order to automate this? So first of all, when we build test automation, we always have to have the same environment as environment of our users. So because I will be automating web page, I need to have a web browser. So right now I'm using Google Chrome. Here it is. I will be using Google Chrome for test automation as well. But keep in mind that most of the modern browsers can be automated. Safari, Firefox, Edge, whatever, they all support automation and they all can be used for automation. Now, besides having a browser, I need to have some sort of magic tool that can talk to the browser and tell the browser what to do. So for example, if I want my browser to open a web page for me, I need to have a way to communicate this to the browser and send this command. So for that, I will be using Selenium. Selenium is one of the most famous tools in test automation. It is the most popular tool in automating web. And Selenium simply allows and like provides some commands that I can use. And these commands will be understood by browser. So in my code, I can, for example, write a command to click on something, and Selenium will just provide me with this command. So when I run this command, browser will actually understand what I'm trying to do. So again, Selenium is just the tool that basically helps me to communicate with the browser and gives me some commands that I can use. Besides that, I will be using a programming language. Today we will go with Python, simply because it's the simplest. And I also need to have IDE, integrated development environment. In human language, it just means like a notepad for coding. PyCharm is the most popular one for Python, so that's what we will use today. So let me quickly show you the setup, and hopefully it will make sense. So this is PyCharm. See, it's right here. So again, this is like a notepad for coding. So here I can write some code, and then I can execute it, right? So I can do right-click run, and this code will be executed. So here you see print something for me. I am also using Python, right? So you see I have Python over here. And today we will be using Selenium. So if I go under preferences, okay, I have tons of libraries. We don't need any of them except for Selenium, right? So Selenium is the one that I will be using today. So that's it. That's basically the main setup to build a simple test case for web. Now, when companies build automation for their products, they usually try to use some other tools. So besides this, they usually use tools like Git that, for example, will allow them to manage code. Some reporting tools that will, for example, provide a summary for our automation. If we have 400 test cases and run them all, how many of them passed, how many of them failed. So reporting tool will give us this visibility. Very often companies use other tools like BrowserStack to run the tests remotely. I will talk about this a little bit later, but we're just going to start with this setup and we will just create a simple test case. Okay, and the last few things, just before we start and jump into coding, just a few words about Selenium. So simply because it's really popular and I feel like it would be really helpful for you to know. So again, we will be using Selenium today in order to control our browser. Selenium will give us these commands for automation. So Selenium has official website, selenium.dev. If you ever are interested in learning more about automation, Selenium, or basically anything related to this, please go to selenium.dev and explore documentation. It's really good. It's like super detailed. It also has a bunch of code snippets with examples for automation. So it's a really, really good resource. And by the way, here's an example, like a reason why we're not going to go with Java today and why we are going with Python. This is a piece of code that just opens Google Chrome, navigates to the Selenium page, and then closes the browser. This is how it looks in Python. And then this is the same code, but this is how it looks in Java, right? So way more heavy. So that's why we're basically going to go with Python, and we'll just do something like this. Selenium is totally free, by the way. This is an open source project, so literally anyone can contribute to Selenium as long as changes are approved by other Selenium contributors. Those changes will be added to Selenium code. Selenium is a tool that automates only web. It cannot do anything else. It can only do web, but it is actually the best tool on the market right now. It has a bunch of sponsors, so like companies like BrowserStack, SaaS Labs, and others really invest a lot in Selenium development and advocate for Selenium. So they are one of the biggest contributors. It's actually kind of funny to go to Selenium website and see how BrowserStack and SaaS Labs logo like swap places. I think it's ordered by the amount of money or resources they contributed in this project. And sometimes you see SaaS Labs first and BrowserStack second. So they like have a competition on this website. But long story short, the tool is absolutely free, and that's one of the reasons why it's so popular, and it's also really good. All right, so at this point, I think we're ready. We can build a test case. So let me start creating it. All right, so let's do it. Okay, so I have my PyCharm. Again, this is just the editor. So in here, I will be writing some code. And here I can just start writing some logic for test automation. So the first thing that I have here, at this point, this file is almost empty. I have a couple of imports. So from Selenium, I'm actually importing a few things that allow me to connect the browser and work with this. Right now, this code doesn't do anything, but as I start typing, it will actually highlight if I start using some of this. So when we build automation, the first step for us is always to connect to the same environment. So in our case, we will be working with web, right? So we need to connect to our browser. And the first line that I have over here is the line that actually allows me to connect to Google Chrome. So this webdriver.chrome command is a Selenium command that allows me to connect to my Google Chrome browser and basically start a new session. So if I run this code that I have in here right now, basically just one line of code, it will connect to my Google Chrome, and then it will open a new window, right? So this is what we see. So this is the first step of our test automation, just to connect to this. You can see that this window is absolutely blank. This is intentional. We don't want any kind of past, previous, like cache or data to modify the behavior of our test case. So that's why we get a totally blank window, no bookmarks, no favorite, what else? No user profile here. So that's intentional. You can see it also says Chrome is being controlled by automated test software. This is coming from Selenium. This is also intentional to indicate that this browser is used by a tool like Selenium. This is done so no one will use Selenium for any kind of bad purposes or like any kind of malware, things like this. So this is just the browser window. Now, when we just open this browser, like our Chrome browser, and have this window, I store it in the variable called browser. So then I can say browser, do something, and it will work with that window. So that's why it's here. Now, I mentioned earlier that Selenium supports a lot of browsers. So it can be, for example, Firefox. It could be Safari, could be some other remote browsers, Edge, bunch of other ones. Again, today we will go with Chrome, but just keep in mind that Selenium pretty much supports majority of the modern browsers. So any browser can be used here. And then when I have this window open, the next step for me is to navigate to a web page. So the next step for me is to go to Amazon. In order to do it in Selenium, we use a command get. So we just say get, and we have to provide the URL, like what URL we're trying to access. So that's what I'm going to do. That's what I'm going to do next. So I'm going to say browser.get. You see, it's already like helping me. It says provide URL, and here I'm just going to populate the URL. So this is the command to open the window. Open a web page. It can be any web page. It doesn't have to be Amazon. It can be google.com, I don't know, Macy's, eBay, whatever. But we will be working with Amazon. So this is Amazon. So now if I run this, come on. Yeah, I think I did. It will do 2 steps, right? So it opens a window and then it goes to Amazon, right? So here we go. And we basically see this website here. So that's the first step of our automation, just get to the right place, right? Open the browser and then go to the right web page. Now, when we are here, let's go back here, right? So when we are here, when we are on this web page, there are actually a lot of things going on here, right? So we see that there are a bunch of different web elements. So there are some images, some text, buttons, links, input field, and so on. In our case, we need this input field, right? So our test case will be to click here, search for coffee, and then verify something, right? So in this case, I basically need to find a way to communicate with this input field, and I need to have a way to tell my browser that I wanted to find me this input field and then do something like populate the text or something like this. In order to do it, I will just use Chrome DevTools. So I'm going to do a right click anywhere on the page, inspect. And then from here, I can basically search for different web elements. So the first tab, elements, is the tab that is responsible for showing you this whole page structure. So like literally everything that you can see on this page, like for example, this image, right? You can actually find under elements. Elements just shows you everything. Like text, for example, right? We can find it here, right? So text is here. Right, so this first tab, elements, is responsible for showing this whole page structure, and we can actually use it to find the element that we need. So over here, Chrome has this like toggle. If I click on it, it'll turn in like this blue color. It'll highlight blue. It means it enables. So this allows me to search for web elements. So I can now move my mouse over different elements on the page, and it will be looking for those elements in the page structure. So I need input field. Now, when it's highlighted like this, it means this element is found, right? This is my element. When I click on it, on the right side in the elements, it will basically find this web element and it will highlight it for me. So when I just click on it now, You see on the right side, it just highlights this element. It says input, type text, ID, value, name, something else. So this is this web element that is responsible for this input field. This is it right here. So again, I'm just clicking here to look for an element. And then I'm moving my mouse over the element I need to find, this one. Then I'm clicking on it. And on the right side, I see it in the page structure. So here it is. And so this is my input. Now this is how this element looks. So inside this, basically, it's input, type text. It has ID, two tabs, actually two tabs, search text box, value, name, autocomplete, and like some other attributes. Now, what's actually important for me here is that this element has an ID. It's really good because IDs could be used as an anchor in test automation. When developers create web pages, if an element has an ID, this ID should be unique. So basically, no other element on this web page will have an ID that is identical to this one. So in my test automation, I can use it as an anchor, and basically I can tell my browser to find me an element with this ID and then do something with it, like populate some text. So that's exactly what I'm going to do. I'm going to copy this ID from here. So again, I'm just like found this element. Now I see it has an ID. I'm going to copy this ID from here, from the structure. And then I'm going to go to my test automation and I will tell my browser to find me an element with this ID and then put some text into that. That's what we're going to do. So we're going to go here and say browser, find the element by ID. This is the ID. Again, I'm just copying this ID from here. So this is how my test automation is connected to this web page now. And then after it's found, we need to populate text. In Selenium, in order to populate text, we use command send keys. Send keys, and we just provide the text we want to paste, coffee. Right, so that's it. Now I'm just going to run everything. So now when I'm running it, we should see the whole sequence. It should go to web page, find that input field, and populate some text. Amazon is incredibly slow. Okay, here we go. Right, so we see that it works, right? It actually populates the text. And then after we have this text, we just need to click on the search button so the search is actually triggered. Same, absolutely the same idea, right? So we have this text coffee in here. Now we have to click on the search button. So we need to find it, and then we just click on it. That's it. So I'm going to use this locator again, click on it. This time I need this button, right? So I'm just going to click here. Here we go. And this is the element that is responsible for this search icon. So it has a different ID, nav search submit button, but it also has an ID, so I can actually use this ID. And now I can connect to this button. So again, I'm just clicking here to search, searching for this one, looking at the structure. If I see an ID, I can just copy this ID. I can go back to automation and say, browser, find element by ID. This time it's going to be nav search submit button, and click. So browser, find element by same ID. This time it's a search button. In order to click on Selenium, we just do click. That's all right. So now if we run it, it should do the whole thing. So it should populate the text, then it should click. And that automates our steps, right? So this just basically goes through the steps of our test case. And now the last thing we need to do will be verification. So after we land here, we also have to build an automatic way to verify and make sure that we are on the right page. But we have all the steps already implemented. So in order to build verification, same idea as in manual testing, we operate with two things: expected result. Expected result is what we expect to see, and actual result. Actual result. Actual result is what we actually see on the page, right? So expected result in my case, after I do the search, is to see the text copy, right? So that is my actual result, just to see this text. So I'm going to copy this text from here and put it under my expected result, right? So this is what I expect to see on the page. My actual result, will be the text that I actually see here, right? So in order to get the actual result, I basically need to find the web element that has this text, grab its text from the web page, and put it into my actual result variable. That's it. So in order to do it, same idea, I'm just going to search for the web element. So here it is. It doesn't have an ID, unfortunately, but it has a class. So this is it, the span class, a color state, a text something, has text copy. So this is my element. Now, because it has a class, I can use class as an anchor too. I'm just going to copy the class. I'm going to go back to my test automation. And for actual result, I'm going to tell my browser to find me an element. Because it's a class, I'm going to use CSS selector and just provide the class. And then after I found this element, right? So after my browser finds this element, I need to grab its text value from the page. So I know what the text is. In Selenium, in order to extract text, we just say .text. So that will take the text. So now I have hard-coded expected result, what I expect to see. I know the actual result, like the actual text that is shown on the page. So in order to do verification, I just need to compare them both and make sure they are identical. In Python, we do it using assert. So we just say assert expected result equals our actual result. If everything is good, we can print something saying test case passed. Right? That's it. That's basically the idea. All right, so let's run it. And now it should go through the whole thing. And it will go through the steps, and then it will automatically check that expected and actual result match. So pretty much all UI automation is all about this. It's just finding a web element, clicking on it, finding another web element, putting some text, finding something else, and so on. That's the idea. All right, so everything worked. We have test case passed, which means everything is good and working. And yeah, that's pretty much it. All right, so I'm gonna pause here. Let's see. Let me do this. So let me answer the questions that we have in the chat. And then after that, we'll do a quick break, and then we'll look at something else here. But for now, let me see what we have in the chat. Cool. Oh yeah, I like that a lot of people like it, actually. Yeah. So what does div means? Okay, somebody's already answering. Yeah, so like in general, and I think it's super important for manual QA engineers, but like every one of those pieces or elements that you see on the web page can be found in this element structure. So everything that you see, like with this opening, basically over here is a tag, like span is a tag, a is a tag, div is a tag. So tags just indicate like certain pieces, like basically structure here. And then everything that you see after that, like data component, style, class, ID, whatever else we've seen before, data index, some UI ID over here, those are just attributes. For QA automation, we actually can use this whole structure to connect to elements. So if an element doesn't have an ID, for test automation engineers, of course, it's easier with IDs, but we can actually use something else. We can also use attributes or anything else to connect to a particular element, and that's it. Okay. What happens if something goes wrong and it finds an actual problem? We report a bug. So QA automation engineers will analyze the run. They will see a failure. Usually we try to reproduce it manually, and then we see that, okay, it actually is broken. So we go to Jira, we create a bug report and assign it to developers. That's it. Same flow as if a bug was discovered by a manual QA engineer, absolutely the same flow. Same fields in Jira ticket, like no difference there at all. What if you need to repeat multiple times? So usually companies will have certain tools that allow to do that. I will show you one of those tools after the break, but there are tools in place that can connect to this code and just run it. Like when I'm hitting run button, like I run it myself, but there could be automation around actually running it. And there are tools in the market that, for example, can grab the latest code and just to run all the tests that are in that code, for example, once per night or once per hour or something like that. Okay, cool. So how do you know what libraries to import? It just like comes with like learning Selenium and learning automation. This is basically coming from that knowledge. That's it. Cool. Would this be the same thing as building a bot? Yes. In fact, many people use Selenium for building bots of some sort, or Selenium is also super popular in data science. Data science engineers use Selenium for scraping the data. So in their case, the code will be like browser, open Google Chrome, get to a page, and then they will like find the element and grab its text value and like store it and like go through like a bunch of listings, for example, and just steal the text from the web page and store it somewhere so that they can analyze it or use it. But totally possible. Automation like that is pretty powerful. Okay, cool. Yeah, so somebody is also asking me like how to put together Selenium PyCharm, Windows, how to do executable paths. I will provide some materials at the end of today's lesson, so that will be covered. In those materials, I actually have like a small playlist with recorded videos, and there is like a setup. So you can just watch the instructions there. Windows and Mac is pretty similar as far as setup. You just need to download PyCharm and install the right things. So in those videos, I basically just cover how to do it. Does the program do or say anything when a bug appears? Usually it should just fail. So let's do this, actually. Let's do a quick break for now. And then after the break, we will continue with this. And I will show you the case when something actually fails. So you will have a better example. Again, this is automation. So as a manual QA, you don't have to do it at all. Yeah. Cool. Okay, so 10 minutes break. If you have any questions, post them in the chat. I'll also double check and make sure I didn't miss any questions. It's 6:38 for me right now, so I'll see you back at in 10 minutes. So it's going to be 6:48. All right, so let's continue. Let me see. I quickly went through the chat. I think I missed one question about somebody said you mentioned that you like to do manual QA more than automation earlier in the course. Why is that? I honestly not sure. I prefer automation, to be honest. I might have said that I do more manual work than automation. That's possible. It's just because in my current project, we do a lot of manual validation for all the new features, and we've already built a pretty big set of test cases for automation. So we mostly do manual testing there and like validate a lot of new functionality, and we don't really do a lot of like new development for automation. A little bit of maintenance, but that's it. So that's why currently, at least, I'm doing a little bit more work on the manual side than automation. I do like both, but automation would be, I guess, my preference, simply because it's a little bit more challenging. So it's kind of fun for me. Okay, cool. So now let's talk about this one. So does the program do or say anything when the bug appears? So ideally, if something is broken, we should see the failure. So in this case, we don't really see a failure. We see test case passed. It also says process finished with exit code 0. Exit code 0 in programming in general just means that the execution was successful. There were no issues and no failures at all. Now, if something fails, we should see failure. So for example, we can break our expected result a little bit and turn it into something invalid. And now if I run this test case, it should mismatch, right? It will see text coffee on the page, but hard-coded text is different. So this code should fail. Okay, so it's checking now. Here we go. And you see that it actually fails. And it points out the line that's failing. It says line 14. So this assertion error. So basically here, when it did the comparison, it failed and didn't execute successfully. It also says process finished with exit code 1. And that means a failure. So this code wasn't executed successfully. So that's what we want to see when something breaks. Now, this is very not human readable and not understandable. So ideally, when people create this kind of verification, they also try to add an error message. So for that, we can say something like error, put it here, expected, and populate some expected text here, expected. Okay, what am I doing wrong? Oops, sorry, not here. In the assertion, in the place where it fails, right? So here we will provide error message, right? So on this line, if something fails here, we will say error expected. We can say our expected result did not match our actual results. Right, so we can put it here. So basically, when our code executes, if it hits this line and this line is failing, it will print this error message saying that expected result and actual result are different. So if I run it one more time, we should see it. It basically will just tell us that there is a problem. By the way, if you have any questions, just post them in the chat. I think I've seen someone raising hands, but it's going to be a little hard for me to like find you, mute, unmute, and things like this. So just post that in the chat. All right, so it's running. It should fail. Okay, so now when it fails, you see this is what's happening. It tells us error. Expected did not match actual. So this is a little bit more readable. We can actually understand what was the difference. So that's it. If we see an error like this, we will report a bug, and this bug will go to developers, so developers can actually fix it. Now, another thing that I wanted to show you really quickly is that very often when people build automation like this, they use other services, for example, like browser stack, in order to run the tests remotely. So I have a short browser stack set up in here. I'm just gonna copy and paste the code just so you see an example. And then we'll try to run this code in the browser stack. So basically, I have the URL that takes to my browser stack account. Then here I have a setup like where I want to execute this test case. So for example, Windows 10, we can say browser Chrome. Let's go with Google Chrome. Amazon test copy. And then when I run this, it will connect to browser stack, and this code will be executed in browser stack. So very often companies will use services like browser stack to run the test remotely. So if I go to my browser stack account, let's see. Okay, browser stack account. Ideally, I should see this test case running in there. So let's see, browser stack automation. Here it is. Okay, and you see this test case is running right now. Oops, I forgot to kill it. That's actually, let me kill it from here. That's my bad. So when the test case executes, at the end of it, we want to close the browser so it doesn't just like hang. Over here, I'm just going to say, first of all, let's fix it. So let's put it back to normal. And I'm just going to say then browser.quit. So after the test case runs, it will close the browser automatically. And now when I run this test case, this time it actually connects to browser stack. So this time it's being executed over here remotely. So just FYI, services like browser stack or Sauce Labs also allow to run the tests using their machines. And this is what a lot of engineers do, simply because it's more convenient. So for example, I don't have to run tests on my own computer where like a bunch of windows will be just flashing and distracting. I can just point my test to run in an environment like browser stack, and browser stack will understand the test. So my test case will be executed. Browser stack is actually pretty helpful because they also make a video recording, right? So basically screen record for everything. And then I can come here, I can play the video, and I can see what was happening. So if something failed, for example, I don't really have to like go and try to replicate it manually. I might as well just go here and watch the video and see what was the problem, what was going on. All the logs are here, right? So browser stack keeps track of everything we're doing, all these steps. Platform device information here, so it's pretty helpful. With browser stack, I also don't have to have Safari or Firefox installed. If I want to use those browsers, I can just come to the setup and say I want Firefox or whatever, and then browser stack will automatically connect me to a service, to a machine running Firefox or running Safari. I can change Windows to Mac, so that's really, really useful. So a lot of companies will be using the service, just FYI, that's another cool thing. And the last thing here, let's see. Let me see if I can actually try to access it. All the certificate issues, but okay, here we go. So the last thing here that I wanted to show you is that very often when companies build solutions for test automation, they try to go even faster and actually automate the lunch and like job around automation. So no one has to go and run the tests manually, but instead people can actually like use some sort of software that will run the tests on a certain schedule. So for example, Jenkins is one of these tools. In Jenkins, automation engineers can just create the projects and then they can configure those projects. So these projects, for example, will trigger the tests, and tests will run like once a day or once an hour or something like that. So for example, here I can build periodically and just set up a certain schedule, so it will work. These kind of tools are called just CI/CD tools. So they allow us to automate jobs around everything. Developers very often will use these tools to automate, for example, going from QA to production, like releasing or building something. In QA, we just use it to be able to run the tests. So if I click this build button, it will just start executing all the tests that I have in this project. And then after it executes, this project also has a reporter, so it will generate an automatic report. So basically, it will generate a report like this that will tell me how many test cases I had total, how many passed, how many failed. Obviously, for 10 test cases, it's not important, but if you have 300 or 400 test cases, that's pretty helpful as far as visibility and things like this. And then it's pretty easy to like go through these test cases, see which ones passed, which ones failed. Yellow or red ones mean fail, green ones mean pass. So people can actually click here and then they can read and like understand what's happening. Very often when automation engineers build tests, they try to add some sort of explanation of what's happening. So for example, here, like I have a test case that like opens Wikipedia main page, then searches for Python, and then verifies that it sees Wikipedia article for Python. So even if a manual QA engineer actually opens this report, ideally they should be able to read and understand what this automated test was doing. So that's like a system that an automation engineer would build. If tests are running in browser stack, it's a good practice to take a link and attach it to the report. So if I click here, it will take me to that test case executed in browser stack. So that's basically how people like build more of like scalable systems like this. So if, for example, you join a company and they have test automation in place, and for example, they give you permission to like go to this tool, run test automation if you need to look at the reports, please don't be afraid of it. You're not going to break anything. You just hitting play button, it just runs the test. That's it. It's not changing any code. But you can actually use it for your own purpose. So for example, in the previous company where I worked, we had a pretty big amount of manual QA engineers and a good amount of developers doing changes. So very often when developers would make like a new build for testing, if there were some major changes, manual QA engineers would actually use a system similar to this, would like click build. It's like in their case, they just needed to like provide the URL for the build, but that's it. It would run automation against the version that was just delivered. So before starting manual testing, they could actually just run some automation and see whether that build is like overall good or not good. So if your company has something like this, long story short, please use it. Don't be afraid of it. It's just running tests. You're not going to break anything, and it could be helpful for you too. So you don't have to test everything manually. You can like just rely on this a little bit. All right, so that's pretty much it as far as examples. So let me go back to the slides. I think there was a question. Is there a way to record a video when not using browser stack, or is it not necessary when you are using desktop? I think you can. I'm pretty sure you can. If not through Selenium, at least you can find Python libraries that will definitely allow you to do it. Usually people don't really do it. If they run tests through desktop, it's usually when they do like initial test case creation and debugging. And then when test case is already created, it usually goes to a system like Jenkins or similar tools. So there they will just use browser stack. There is no need. Yeah. Cool. How do you record a video and put in Jira for bugs? So for that, you need to have like some software that allows you to make a recording of your laptop. I'm honestly not familiar with Windows. Maybe just Google it. But for Mac, I usually use QuickTime Player. So QuickTime Player actually is default software that goes with Mac, and it has video recorder built in, so you can just use that one. For Windows, I'd say Google would be my best answer, or you can ask our support at Careerist. I'm sure they have some recommendations too. Okay, so let's continue. We've talked about some commands, talked about browser stack. A very common question people usually ask me, is mobile automation possible? Can we automate mobile? What's the good tool? And all that. Mobile automation is totally possible. Just like web, there are tools that allow you to connect to mobile devices and build some logic to automate. There are a lot of different tools and a lot of different frameworks that you can use. Most of the frameworks that exist on the market, like most of the tools for mobile automation, unfortunately only support one platform. So they can either automate Android or they can automate iOS. There are only small amount of tools that can automate both. One of these tools is called Appium. So Appium is a good tool that allows you to automate both mobile platforms, basically iOS and Android. And Appium is the tool that is super similar to Selenium. Appium, in fact, is built on top of Selenium. So I'm not going to run it, but I will show you. I think I have it somewhere here. Appium script. Here we go. All right, so this is an Appium script that just automates small thing for Android. So you can see that it's really similar, right? It's just, instead of browser, we just say driver find element by ID. It has a different ID. Click, send keys, right? Clear, send keys, find element. Grabbing text, right? Assertions at the end. So Appium and Selenium are really similar. If you think of like learning automation, I would recommend you to go with Selenium, learn Selenium. And then after that, you can learn Appium, usually within like 2 weeks, because it's literally the same commands. All that you will need to learn here on top of Selenium is just how to connect the mobile devices, but that's it. So just FYI, this tool exists. Appium, basically, as I mentioned, just reads your test automation code, and then it works with both iOS and Android. So it understands the command of your automation code, like find element and click, and then it translates it to the command that iOS or Android understand, depending on what you're testing. It executes that command, and then it just basically provides the results back to you. So it's a good tool. Again, more just FYI, if you join a company and they mention something about Appium, or they say something that they use Appium, whatever, that just means that they have mobile automation, and Appium is the tool that they use for it. That's it. All right. Cool. Let's see. Let me check the chat. We do have like a few interview questions I want to go over next. But before we get there, let me quickly check the chat, and then we'll answer some common ones. ChatGPT. I actually use ChatGPT if I need something. For example, like if I'm trying like to schedule an automated job and like run it in a certain time and hour, it's simpler to just go to ChatGPT and ask like how to set up, for example, Jenkins to run every hour, and it will just give me the answer. I just copy it and use it. As far as building code, I actually played with it. It's not as good as senior level engineers for sure, but I would say it creates a decent like beginner level code. So I teach a lot of our QA automation students. So I would say like ChatGPT and their code are pretty similar. So that stage, it's pretty similar. Eventually, I'm sure it will become better, but for now, it can't really build like super complex systems. But for a simple task, if you ask it to automate something like this, like this that we just did for Amazon, it'll probably do not the perfect, but it'll do a decent job. Okay. Cool. Mm, yeah, so about mobile automation, does it automate the simulation? Two ways. Usually when we build the tests, we use a simulation, like I can use Android Studio to open one of the devices and connect to that. But then for running tests, we usually use physical devices and we use browser stack. So instead of actually like connecting the device to our computer, most of the companies will just use browser stack. And basically here they have this app automate product. I can just connect to a mobile device and it will run the tests remotely on a mobile device. It supports a bunch of frameworks. There is a good variety of the devices, so it will be just like a setup similar to this, but instead I will say something like Android 12, for example. It's going to be no browser, like some name of the test case. Yeah, and that's pretty much it, actually. Oh, and there's going to be, if I have an APK file on my computer, there is also going to be like app, and then it will take to like something dot APK, and that's it. So that this code will actually connect the browser stack. So that's how most of the people will do it for mobile automation. Okay. For manual testing, yeah, you will be using real devices, so they will just test you. I'm sorry, they will just send you actual devices for testing. Okay, cool. So let's just cover these questions that I have. They are pretty much like very common and something we've already answered. But let's just like summarize. I don't think anyone will ask you a lot of questions about automation. Again, you are manual QA engineers. You're not expected to do anything related to automation, coding, scripting, things like this. But just in case, let's comment the most common ones, and let's start. So the first question is actually quite common. How familiar are you with test automation? This is something that a lot of managers usually ask. So keep in mind that when you are applying for a position, if the title says QA engineer or QA tester or regression tester or I don't know, manual QA engineer or something like this, these are manual positions. So even if the title is QA engineer, it's still a manual position. People who are applying for automation will be going for titles like QA automation engineer, test automation engineer, software developer in test. So those would be automation titles. So when you're applying for a QA engineering role, you are competing with other manual QA engineers. So automation engineers are not going to be applying for those roles. So that's important to keep in mind. Like, don't expect that everyone's like expecting you to know everything about automation and be able to code. They just ask this question to understand your overall level and get an idea, basically, how familiar you are with this. So just be honest. We usually recommend to say here that, I have a good idea of what test automation is. I don't have any hands-on experience with automation, but if there is a chance to learn test automation in your company, I'd be happy to do it. So something like this. I know some of our students were using kind of this lesson and they would say something like, oh, I had one lesson about test automation. It was pretty cool. I learned some basics of Selenium. If you feel comfortable to mention that, feel free to do that. But if you don't feel comfortable, no need to mention it. You can just basically tell them that you know the overall idea, you don't have hands-on experience, and that's it. Please don't tell them that you know automation. If you don't know automation, it's too easy to catch. So like, please try to be honest with this. And that's it. Again, most of the manual QA engineers really don't know anything about automation. So at least if you understand the concept, if you get the idea behind like test pyramid, that's already pretty good. Question number 2. What types of testing are the best candidates for automation? So everything that is repetitive, basically smoke testing, regression testing, are first candidates for automation. Everything that we can't do manually, we can try to automate. So for example, load testing, when we simulate situations of like thousands of users accessing our app at the same time, that is something we can try to automate. We obviously don't have thousands of QA engineers to test something like this, so that would be another good candidate for automation. But that's pretty much it. And then question number 3, opposite, what kind of tests are not recommended to automate? So here we have everything that either is impossible to automate or something that just doesn't make sense to automate. So things that are impossible to automate are, for example, things that only manual QA engineer can do, like making sure that the app is user-friendly. Like going through the app, make sure that it's easy to use, there are no problems, it's understandable. That's something that manual QA engineer can do. Automation cannot do anything like that yet. Besides that, things that basically like doesn't make sense to automate from common sense perspective are all kinds of like short-term things. So temporary events, temporary functionality, some temporary like interfaces or deals, or something that will exist in our app for only a few days or maybe a couple of weeks. We usually just test manually. We don't automate those kind of things. Styles and design, we usually don't automate. We just test it manually because in order to test and make sure that app looks good, we can just open it, quickly click through the screens and make sure that, okay, it's all fine, right? We don't need build complicated systems for that. We can just spend 10 minutes and manually validate it. Also, all kinds of edge cases, like tapping on a button 10 times, making sure it doesn't break anything. We usually also don't automate. That's something that manual QA engineers would do. And new functionality is also usually not recommended to automate. So new functionality is usually tested manually. And then automation will come later if we decide that we're going to keep that functionality in the app and we're not going to change it. So that's pretty much it. Question number 4, benefits of test automation. So we covered that at the beginning today. It is fast, it's reusable, it's reliable. It eventually reduces the price of the QA in general, and it leads to a good test coverage. If we have manual QA engineers and automation engineers, we can achieve a really good coverage. That's usually the main benefit here. Question number 5, what can be automated? Also covered today, I think one of the first slides. Pretty much everything that has interface, web pages, mobile apps, iOS, Android apps, desktop apps that you install on your computer, like, for example, Microsoft Word or whatever, all those things could be automated. Unit tests can be automated. Also, that is usually a responsibility of developers. Service level tests can also be automated. Also, that is also a responsibility of developers usually. Question number 6. I don't think anyone will ever ask you, but because we've talked about it for so long today, let's just like summarize this one. You can definitely answer this one. What is Selenium and what can Selenium do? So Selenium is the tool that automates browsers, and Selenium just gives us these commands that allow us to communicate with the browser. So today, when we were creating this code, right, for web automation, we were using a bunch of Selenium commands. So this .get command to open a web page, this is a Selenium command. Find element is a Selenium command. Send keys, click, grabbing text value, this, all of this are Selenium commands. Quit is also a Selenium command to kill the browser. So Selenium is just a library for like all these commands. It gives us these commands that we can use in our code and control the browser. That's it. Selenium can only be used for automating browsers. So that's basically what the website says. Selenium automates browsers. That's it. Selenium cannot do anything else. So Selenium can't do like mobile automation, or Selenium cannot connect to the database, or I don't know, make a request to some server or anything like that. It just can't. All it has are just browser commands. So it just gives us these commands for controlling the browser. That's it. And the question number 7, I also don't think anyone will ask you this one, but I kind of wanted to add it here just to talk a little bit more about the concept. So let's say you join the company and they have test automation implemented. So the question is, how often should we run these tests if we have them? So long story short, every time developers modify something in the code, there is a chance that they will break something. So ideally, after every development change, we should run tests and make sure that they didn't break anything. This being said, sometimes it's impossible, especially if you have like 20 developers who constantly change something. You can't be just like running automation 24/7. It's just basically impossible. So at minimum, we should run test automation once a day. Many companies will just pick this approach, and then they will just execute all the tests that they have once per day and make sure that tests are actually passing and like no bugs are discovered. With this approach, if automation is executed once per day, basically you still get the results pretty quickly. So if something was broken the day before, you will just find out almost right away. So that's good enough. Now, at minimum, like for example, if even once a day is impossible, at minimum, we should run automation before the releases. So if for some reason we can't run it more often than once a day or once a day, we must execute it before the releases and make sure that we're not releasing any bugs. If you join a company and they have like automation engineers or even some automation, and you see that this automation never runs or they never really use it, it just means it's not sufficient, right? You can't really use it and rely on the results. And it basically means that for that particular company, it's more efficient to rely on manual testing. So at this point, we should just throw away automation and we should keep on testing manually. So there is no point to have automation and not use it, not run it. So if that's what's happening, don't waste time on it. Just concentrate on manual testing. That will be more efficient. So that's it. And that's basically the idea. Now, I do have some additional resources before we jump here. Let me quickly check the chat. And that's pretty much all I have for today. So I'm going to answer the questions, and then I will quickly share some additional resources that could be really helpful. All right, let's see. There are many interview questions provided with answers in previous lessons. Are we supposed to memorize them all or just most common interview questions? So you will be working with mentors on this. There are definitely most common questions that we recommend you to learn. Don't try to memorize them by heart. It's better if you understand them and like basically explain things with your own words when you answer those questions. It just sounds better. But ideally, we would expect that you would like read through the whole file and at least be familiar with most of the questions that are there. And then when you start working with the mentors will definitely concentrate on the most common ones, and they will definitely practice those questions with you. So you'll be going through the process, and there is still going to be like a lot of practicing of that part coming up. Okay. Yeah, so like please don't be like nervous. You will be practicing them with mentors first, and then mentors will provide some feedback, so they will help you if something's not clear. They will explain all those things. And only after that you can start interviewing. So when you actually start talking to real companies, you should be really, really well prepared. We did try to make that like whole file pretty big. So pretty much everything that people can possibly ask you is in there, in that file. We rarely get feedback that people ask us something that's not on that file. So that's why it's so big. All right, so let me share some materials. Hopefully they could be helpful. So first of all, I mentioned that I have a small set of videos that explains test automation setup and some basics. So I have this small YouTube playlist. It's, I would say, probably like 2 or 2.5 hours of videos where you can just look at some basics. So today we didn't do any like tool setup, right, or project setup. I was like, hey, this is PyCharm, let's just code. If you want to build automation yourself, you obviously will need to set up the correct environment. So here I have a few videos about this. Feel free to just explore that. I also go over some test case creation, will be similar to what we did today, but then I go a little bit deeper into like concept. I actually break it into the test case. I talk about like different ways of locating elements, like what if an element doesn't have an ID? What do you do, right? And some basic commands. So this could be helpful. Feel free to just explore that. It's also free, right? I know some people like to kind of learn something before they join automation course and like test it out. So that's a good resource. Let's see. Besides that, we have intro to test automation video. So this is the video that we did with Careerist a couple of years ago. It will be really similar to what we covered today. But if you're interested, check out this one. The difference here is that I think I automate Google, not Amazon here, but the idea is pretty similar. So besides that, we also have a QA automation course. So if you ever are interested in test automation, this is where you can find me. So Careerist Automation, or you can go to Programs, QA Automation. And then here you can find all the information about our test automation course. Most of the lessons are taught and created by me. But also the second instructor is Vitaly. I think you met him during this course as well. So I will be teaching all kinds of lessons devoted to Selenium, automation, browser stack, like all kinds of tools, things like that. And Vitaly will be teaching lessons devoted to some tooling around automation, like Git, some basics of HTML, CSS, and more advanced Python, and like preparing you for coding interviews. So that's his part. This course is pretty big. Let me see if I can quickly find syllabus. I can never find it on this website. Okay, here we go. So it is 15 weeks. So you can basically just like look through the main parts here. But basically around 60% of the course will be devoted to actually automation, learning it, building it from scratch. And then the remaining time will be devoted to some additional tools and learning how to pass coding challenges, just because it's pretty important for QA automation interviews. Another thing here is that we have, let me see if I have this on this website. Here we go. We have 2 classes per week. So for test automation, if you consider in this course, we have 2 lessons per week. Each lesson is 2 hours, but we also have a lot of homework. So keep in mind that you will probably spend, I would say, like 8 to 10 hours total per week in order to watch the videos, practice, and actually do some coding. Same as with manual QA, we have internship with automation. It lasts 3 weeks. We also have one-on-one mentors that will help you to prepare for interview. We do have 2 categories of mentors here. We have mentors who will help you prepare like all kinds of behavioral questions and things like that. And then mentors who will practice all kinds of like coding and automation related questions with you. So that's basically what you can get here. So that's our course. We also have a Python course. So if you, for example, join automation, Python course is included. But if you're just interested in Python, we have this course that just includes some basic lessons on basic Python. So it's this is the price. So this is just Python, only Python, and no automation. If you're interested, feel free to explore that as well. And I also added a few links for like other resources. So for example, if you want to explore Python and like try it for free before like taking any course or signing up, you can do that as well. Just keep in mind that you don't want to use anything that says Python 2. Python 2 is deprecated, but any resource that says Python 3 is pretty good. People use Python 3 these days. Python.org is a good one. It's the official website. It has some good information. The third resource is a good one. The first link is a good one as well. So feel free to use the resources from that blog post as well. And I added a couple of links. So the link to Python and Selenium official documentation has a bunch of Selenium examples with like code snippets and stuff like that. That could be helpful. And also Selenium, as I mentioned, selenium.dev documentation. That is also a good resource to read about automation and like find some examples for coding. So that's it. All those links are available. If you go to your course dashboard and like open this slides, like slide number 15 has all those links clickable. And so you can just explore these materials. Again, this is not required. This is only if you are interested in automation. All right, let me know if you have any questions. I'm going to pause here. Feel free to drop off if you don't have any questions. I'm sorry for going a little bit over time, but I'll just stick around for another couple minutes and I will answer things and questions that we have in the chat. Okay, somebody's asking me, oh, somebody already posted the channel. Yeah, I'll post the link to YouTube playlist as well. Yeah, so that's that one. All right, cool. Let's see what else. I'm sure internship mentorship will cover, but tips on remote jobs interviews. There are usually no difference as far as like interview process for remote jobs or on-site positions. It's just the same set of questions. The only difference will be when you actually like start working. So for the remote position, you will be a little bit away from the team. So sometimes you will actually just need to schedule some additional time with managers or mentors, whoever you have in the company, helping you with the onboarding. To have a little bit more face time, but that's usually the main thing. And if you have any questions, or like, for example, if you started a particular job and they ask for something that you don't know how to answer, don't afraid to ask questions. So you can always ask them. If they say something that like doesn't make sense to you at all, you can also reach out to us and you can also ask us questions. So we will try to like support and help all the students who start new careers, so they are not like totally lost. Okay, cool. Let's see. Yeah, thank you for positive feedback. Again, I really like to see some folks who are interested in automation. You don't have to know automation. It's not for everyone. It's totally fine if you don't like it, by the way, but I like to see that some folks are interested. Okay. Let's see if there are more comments or questions, but cool. Yeah, and somebody says I have to rewatch this video. Yes, it's totally fine if you didn't get something. Like, don't worry that That's okay. That's normal. So keep in mind that you always have these recordings. You can always go back to this one. And again, this is more of like additional content. So as a manual QA engineer, you don't have to do automation. So if you like get high level idea, that's already pretty good. Obviously, you don't need to like know these commands and know how to do it. This is just an example, so you understand what test automation engineers actually do. Cool. Somebody's asking me, I like that this question comes private pretty much all the time. Somebody's asking me about the salary difference between automation and manual. It actually depends, but again, the best resource is just levels, right? So levels.fyi, you can just like search for testing here. And this will give you like some good information. In general, test automation usually starts with, I would say like 115, 120, and then it's more than that. Like senior level automation will be, I would say around like 160, 180 plus, depending on the company. But like the salary range is pretty wide. But if you explore levels, you can like find some actual examples. And then if you like open these examples, you can kind of guess whether it's automation or manual testing. Unfortunately, it aggregates everything. So sometimes it's like a little bit hard to say. But if you create an account here, you can usually guess. All right. So again, levels.fyi, it's a good one, but that's pretty much it. How does levels compare with Glassdoor? I like levels more because Glassdoor aggregates a lot of old data. So sometimes on Glassdoor, you see information that is not really relevant to the modern market. So like they show you, I don't know, 90K average, but actually average is like 100K or something like this. And the reason for that is because Glassdoor takes a pretty big time frame, and then they calculate like the average for, let's say, for example, half a year or something like that. I'm not sure what exactly they're doing. And when they do that, they also take postings into the calculation. So if a company makes a job posting and provides salary, Glassdoor also uses that for calculating average. But when companies do this job postings, if they post a salary, they intentionally put it lower, below what they actually ready to pay, because they hope to find someone for cheaper and like they can negotiate with the person. So that's why Glassdoor always shows a little bit less. But like I used to explain to people, if you're looking at something and the particular number at the Glassdoor, just add another 10,000 to that at least, and test the market. When you talk to a recruiter, take Glassdoor number, add another 10K, ask them for that, talk to like 3-4 people. If you give them this number and they like all fine with it, when you start talking to the next person, add another 5K. Like try to test the market and see like basically what is the right number. When you start hearing that people start saying, oh, this is too much, or this is a little bit stretched for our budget, that means you're good. That means that's like the right spot. So you don't want to go like above that. You want to be somewhere around that number. So that's the way to test it. Cool. Can you touch on junior, middle, senior levels as far as time frame? If I get a job tomorrow, when would I be considered a senior engineer? Yes, a junior usually is someone who has like less than 1 year of experience. Most of the people who have like 1+ year of experience, that's kind of already middle level at this market. So it can be 1 to, I would say, like 3-4 years of experience would be technically middle level, and then senior usually will start after that. But with this being said, it actually not really connected to the time frame. It's more connected to the skill set. and your ability to change the jobs and actually like get promotions. So for example, if you join the company and you're the first engineer, so you started as a QA engineer and in half a year they turn you into a lead and gave a lead title. When you start looking for the next opportunity, you already have leading role, so you go as a lead. Or if you like learn some technical tools, and for example, you've been at this job for 1 year, but you've learned all the basically stuff that their senior engineers are doing, you can ask for promotion or title change, or you can start looking around and explore other opportunities and apply for senior positions. If you find one of those, you can just change that, like your role to senior and be senior. So that's like a short, it's basically like a shortcut if you don't want to wait. I usually don't recommend people to sit at the same company for more than 2.5 years. It's better to actually change jobs, or at least like hopefully get a promotion, because otherwise there is a good chance that you will end up underpaid, because market's developing very fast and salaries are growing way faster than the raises that they give you. So that's why it actually, like from financial perspective, it makes sense to change jobs. And every time you change job, just ask for another like 10 or 15K on top of what you're making. That's the fastest way to go from like 80K to 140, for example. Yeah. So somebody's also posting a similar answer. Yeah, exactly. That's exactly it. All right, cool. So I think this is it. I don't see any more questions. Thank you everyone who joined. Good luck with your next steps, right? Good luck with your internship. You're pretty much done. And I hope to see you among my colleagues soon. So yeah, have a good rest of your night. Thanks again. Bye-bye.